So, good morning, everyone. Chandana?
Yes, ma'am.
Yeah. The screen is visible, right?
Yes, ma'am.
Yeah. What are the low-cost waste treatment methods that I talked to you yesterday about?
Ma'am, septic tank and oxidation pond.
Oxidation pond. So, in that, we had already covered with the oxidation pond, correct? So,
Yes, ma'am.
I had mentioned that we can call it as stabilization ponds, and usually these ponds are kept to be kept shallow. Why these ponds need to be shallow, or they shouldn't be of great depth? Can you tell me?
Is it for me, ma'am?
Yes.
Ma'am, I believe the oxidation pond should be shallow so that like the sun rays can fall evenly and so that it can be disinfectant.
That is sun rays. One component is disinfection. That I will agree with you, because sun rays have that UV component which act as a disinfectant, and some amount of those pathogens and all get killed. That is one component. What other uh, benefit having shallow? But what happens if it is too deep? Let us think about that. If your pond is or a lagoon is a little deep, you are sending in wastewater which has got a high concentration of organics, solids. Inorganics also will be there. So if you have too much depth of this liquid retained in a pond, what type of conditions do you think will get developed inside, especially towards the bottom?
Ma'am, formation of algae and all of those.
No,
Bacteria,
not
algae.
see. When we ask condition, it is whether the state of that system is aerobic in nature or anaerobic in nature. We are very clear with the terms aerobic and
Anaerobic.
anaerobic, right? Yeah. If you
Anaerobic,
have
ma'am.
too much depth, see, even in a shallow lagoon or pond, the bottom layers tend to become anaerobic because of deposition of material one on top of the other. There is non-availability of oxygen to the bottom layers. So if we try to keep the oxidation pond in a depth wherein the exchange of gas between the water or the wastewater and the air is possible, then chances of maintaining an aerobic system is more. Okay, so that's why they say they are kept low. And about the sunlight, what you said, UV component of the sunlight is definitely beneficial in disinfecting the liquid in terms of the pathogen content, but also this sunlight gets used up by the microbes or the microbic or the small sized phytoplankton. It gets used up by the algae, and in turn these plant forms will give out oxygen, which will be then available to the microbes, that is the bacteria, which can act on these organic solids which are present in your wastewater and decompose them. And we also saw that this is coming under the low waste treatment, low cost waste treatment category, and because of which this is usually a single step of treatment. You will find many industrial estates or even industries like paper pulp industry, where huge quantity of wastewater with lot of solids, because pulp is an organic matter. They do some amount of treatment, and then in the later stages, as a polishing effect for that, they put it into an oxidation pond. So you will find these oxidation ponds in many of such industrial units or industrial establishments, industrial estates, etc. So I think I showed you this figure, and we were looking at this is the representative diagram. Okay, so ponds, oxidation ponds are supposed to function in an aerobic manner, but there can be anaerobic lagoons or ponds also. And if you look at the bottom portion is where the anaerobic effect happens, and that is because of all the solids that are deposited on the top, which will get easy access to the oxygen, and the organisms responsible there will be aerobic in nature. Because of the lower layers getting deficient oxygen, the organisms that survive there automatically get into the anaerobic category, and so these organisms are responsible to create the anaerobic environment there. So this is the consideration for an oxidation pond. Now the second one was a septic tank. Now septic tanks are basically, if you see, first we can ask why a septic tank comes as the low cost treatment. See, we all know that in cities, most of our areas are coming under the sewerage system. Okay, but if you go a little towards the revenue areas and things like that, in such places, the sewerage network would not have been laid down by the municipality or corporation, whoever is looking after that. So because of that, when the houses or buildings are getting constructed, they create a single point of treatment, which is called as a septic tank. And that is very low cost, because you just need to create a RCC, or nowadays even those concrete rings are available, so you can make it out of that. You just have to make one tank wherein your wastewater along with all the solids coming from that gets into that tank and remains there for a period of time, and only once in a while you will be cleaning out the sludge part of it. So hence it comes as a category of low cost treatment. So in many of the unsewered areas, even in Bangalore, you will find such type of septic tanks. And as we all know, in cities like Bangalore, where the site cost itself is very high, people are not willing to give up the land for construction of this within that 30-40 or 40-60 site they're having. And so most of the time you will find these septic tanks are, or pits as we call it sometimes, are located on the road. Okay. And always, if there is a septic tank, there will be an associated tank along with this tank, which is called by the term soak pit. Okay. So if you have seen a septic tank, it is constructed under the ground. It can be constructed both of masonry or RCC, but you need to have a very strong floor and you need to have very thick side walls, whether you are having it of masonry or RCC. And the top will be given as an RCC slab, and you will have an opening or an access so that somebody can enter into the tank, and for cleaning purposes, things like that, that will be there. So the size of the tank is usually based on the number of occupants in the building, and the design features take into account those things. Now, it is actually a sort of primary sedimentation tank, like we are studying in the case of your water, and even coming to wastewater, we will have a sedimentation tank. But the only thing is, in your sedimentation tank, if you have a detention time of 2 hours or 4 hours like that, here the detention time is much longer, and the solids will remain in the tank. The liquid portion will be, there is an effluent outlet. Through there, it will go into the next chamber called as the soak pit. So the sludge always remains at the bottom. And when you have a septic tank, you will be probably having the associated soak pit next or adjacent to the septic tank. So if you look at it, it is a typical underground tank in which the sewage is collected, allowed to decompose, and this decomposition that takes place is anaerobic. So in the case of septic tank, the biological process that happens within the tank is completely anaerobic decomposition. So the tank itself has got 3 specific zones. The inlet zone is there, the sludge zone will be there, and the outlet zone will be there. So the sludge remains at the bottom. In the number of chambers of the septic tank is also decided upon by the number of people who are using the facility, or if it is the building, hospital, whatever it is usually designed on such. So, since it is a sedimentation cum settling tank, it has to perform both the function of sedimentation, digestion which happens because of anaerobic decomposition, and the sludge which will settle down there. So once the sludge settles down, you will have a little bit of scum and water floating on top of the sludge. This water will just go out through the outlet and it will be taken to the soak pit. So the tank should be large enough to take in three requirements. The first one is the sewage flow. So the maximum sewage flow into a septic tank will be based on how much wastewater is getting discharged. So if it is a unit of a house, the number of people, the number of outlets like closets, wash basin, sinks, suppose your washing machine waste drain is connected, that all these facilities together, the number of points that you're having, along with the usage of water, that will give you an approximate consideration of how much wastewater, and then your tank has to be based on that. So that in the tank, you will have a place where the sedimentation or the settling is happening, and you will have the sludge digestion area of the tank. And at the bottom, you need to design a space wherein the sludge can be stored for some time. So in a normal household, normally once a year, sometimes if the number of members are less and you have built a sufficiently large one, probably once in 2 years, the cleaning will happen. And usually this cleaning in the previous years used to be done by manual labor. But nowadays, all of you have seen that vacuum suction equipment, which goes by the funny term of honeysucker. Okay, you can insert the tubing into that, and through vacuum suction, it gets pulled into an airtight tank. And so without much nuisance, the tank can be cleared out of the sludge. So in this case, the design, detention time will go for about 24 to 48 hours. And it will also depend on how much size you have designed your tank for. Suppose you have built a little more larger tank, you can have a detention time slightly longer because more amount of fluid will be able to be retained there. Else, that will be the time for which the septic tank is drawn. And in this particular figure, they have not shown any facility for venting the system, but usually a vent pipe will also be provided in these types of tanks for the same purpose as what we were talking about yesterday, that in a sewer pipe, when anaerobic conditions are being developed, there will be a large quantity of gas getting generated, and these gases should not build up here. So because of which a venting system is also usually provided. So a septic tank is a watertight tank designed to slow down the movement of raw sewage and waste passing through, so that the solids can separate out, settle down, be broken down by the bacterial action, which is anaerobic action. It does not purify the sewage. So septic tank is not meant for purifying, but it is reducing the organic pollutant capacity and stabilizing the solids that are present there, eliminating odor and destroying the solid matter. The septic absorption system, without clogging, you do not allow the solids to clog the system. The suspended solid removal goes up to 70% when you talk about a 5-day BOD. It is about 60% removal. So BOD can be reduced by 60% and the solids are reduced approximately up to 70%. So once this system is done, you need to have the associated soak pit wherein You have a large tank into which they have put a lot of aggregates, okay, and the effluent that comes from your septic tank is allowed to seep through these aggregates, and these aggregates act like a filter media, as in the case of your water, and even in wastewater we have something called as a trickling filter. So because most of the solids, you saw 70% is removed, so hardly 30% solids will be there, and because of that, this filter media will be able to retain most of the other solids within that, and the effluent, once it passes through the soak pit, is generally allowed to seep through the surrounding soil by the time most of the solids are supposed to be removed from the wastewater. So you can see the detention time. If your septic tank is large, like I told you, you can have more hours. But 24 hours will be the general consideration. 48, 56, 72, all that depends on the size of your tank. If you have more, then you can definitely use it for a longer time. So this is generally what is the septic tank. So first thing, septic tank is a low cost system. Okay. Secondly, why its importance, if you are asked, it is very, very important where unsewered areas exist in cities. Then the only way in which the waste from that building can be taken is through or passed on through a septic tank, and it's a one unit treatment. Okay, so that also reduces the cost. Then suppose you have a hospital building or a hotel building which is separate from the city or away from the city. Okay, so there having a sewer pipe just to connect that one building becomes very difficult. Similarly, if you go a little away from the city, you will see that the in the town or even in the semi-rural or semi-urban areas, the buildings are far apart. In the city, it is very easy to lay the sewerage system because the houses are so close to each other. Laying the lengths of pipeline, you will have so many connections coming to it. But in the rural or in the semi-urban areas where there is a widespread building, or the buildings are widespread, then you will have length of sewage which is used to connect one building to the other, and you will have hardly one or two connections along the way. So it proves to be highly uneconomical in areas where you have very long lengths of sewer pipe to be laid, but the number of connections are coming to be very less. In such areas, definitely it would be preferable to have a septic tank. And next is, suppose a building wants to take care of its complete treatment by itself without having to pay any corporation or municipality, things like that. They can design a very good system wherein they are able to treat their waters properly, and they can use that treated water as subsurface irrigation. If they have agricultural land, it can be sent to the subsoil there so that it moistens the root area. But by that time, it would have been cleared off from all the solid matter that is present in the wastewater which comes to the septic tank initially. So whenever you think of septic tank, think as a soak pit attached to it. Both systems work together. So this is about the low cost treatment unit, which is being included in your first module because this does not get covered in any other space. So a repeat once again, the purpose of low cost treatment is, one, when you don't want to give any other associated treatment to your wastewater. So you are not having any industrial sewage, nothing is getting mixed. Okay, only say municipal wastewater which you want to treat in one step, either in a septic tank or in an oxidation pond. The cost wise, there is less in terms of construction. Their maintenance is also relatively easy. Only at periodically you will be clearing out the sludge either from the pond or from the septic tank. Hence, called by the name low cost treatment. You have oxidation ponds where you have very little large land area to be utilized, whereas the septic tank is an underground tank. So these are the systems available for you for low cost treatment. So With that, the low-cost treatment portion is over. The next topic that we have to look at is sewer appurtenances. We have seen pipe appurtenances in the case of water supply system also. Okay, you have seen about sluice valves, gate valves, air relief valves, pressure relief valves, so many types of valves and appurtenances. These are put into place in the system so that the water is able to flow in the pipeline very smoothly without causing any airlocks, blocks and things like that, and in some case to build up pressure and things. So here we are talking about appurtenances which are put in a sewerage system. So there, if you have the pipe network, here you have the sewerage network, and the appurtenances fitted on the sewerage network go by the term sewer appurtenances, of which the first and most important one is a manhole. So why the term manhole? So if you go to a main sewer, we talked about trunk sewer or main sewer, branch sewer, laterals, etc. Laterals are very small pipes, so the size of your manhole also will be very smaller. But if you go to a very large one, you can see, especially in some of the movies, you would have seen large sewer things through which people are. You can see even the people are able to move within them very freely if there is very little amount of flow. So manholes are constructed structures, and like I was trying to tell you when we were talking about laying of sewer lines, usually the sewer line is connected from one manhole to the other, and then like that, stretch by stretch, they finish the work. So these can be built again of concrete, or you can have it of RCC, and these are built for the purpose of an inspection team or an inspecting personnel to be able to enter into the chamber if there is a major problem, and to identify or rectify these problems or carry out maintenance activities. Then that is why the term manhole. So they are masonry or RCC chambers constructed at suitable intervals along the sewer line. Now, where is it necessary to have a manhole? Is suppose your sewer lines are perfectly straight, then you can have manholes far apart, 200 meters, okay, even 500 meters apart, because the length of the pipeline is laid straight between them. But suppose there is a change in direction, there is a change in gradient. That is, what happens? The branch sewer line is at one level and your main sewer line is at another level. So both the pipes are not meeting at the same level. Okay, so if you have change in direction in the sewer net pipe work, or you have change in gradient and along straight lengths at some distance apart, we will have the construction of a manhole. Okay, so when you describe a manhole, you should tell the purpose and how or where they should be located. Now, they can be made either of RCC, or you can make them of masonry also, depending on their depth, the size that we have. We may have a shallow manhole, because sometimes a small chamber constructed in the wastewater system will also be referred to as a manhole, because it is a connecting chamber for the pipeline. A normal manhole is a depth of manhole where you have it about 1.5 to 2 meter depth. Deep manholes will be little more deep compared to the normal standard manhole that we have. So you see, if it is a shallow manhole, it will be less than 1 meter deep. Okay, so it is constructed at the start of a branch sewer, or at places where you do not have heavy traffic. So when the depth of manhole is shallow or low, less than 1 meter, we define it by the term shallow manhole. Such manhole is provided with a cover and just one chamber, which we call as the inspection chamber. So like I was telling you, wherever you have general domestic areas where you need to provide a chamber, because even in the small pipelines in your crossroad, you will have to put in a manhole, because if there is any block happening from one building to the other, the sewage water is not flowing, then if you want to take care of flushing the sewer and things like that, these manholes are required. Understood? So there is a purpose for which these shallow manholes will be used. And the deep manhole, which is having a depth greater than 1.5 meters. Okay, the size of the upper portion is, that is, you, when you see the figure, you can, it looks like a truncated, or a, what is saying, a trapezoidal area at the beginning. So you have a narrower neck and the working chamber, because the chamber is divided into two sections. The first part of the section is through which the person will be entering, so that will have a slightly narrowed head, whereas the working chamber is the place where, they may have to do some construction. Sometimes the pipes move out of place and they have to replace the bedding and things like that. So there should be a moving area around that place, so that is referred to as the working section. So that will be a slightly larger. Okay, so the size of the upper portion is reduced by offsetting, and usually you will have a ladder, okay, a metallic one, or a steps created along the side, like into your water sump. You will probably have kept a ladder or put steps to enter, right? In the similar way, you will have it. Now we will just quickly look at a manhole. So this is the typical sketch for a manhole. So this is what I was trying to tell you. Construction of this is a costly process. Now this part is just the access shaft. Understood? So the total depth of this may be, if it is deep, it may go up to 2 meters also. Okay, so you have this part of what is called as the access shaft, and only this will be visible to you above the ground. So you will see a concrete or RCC covering with a small cast iron lid, like, which can be, so there will be an Allen key thing, so that nobody just opens it, and only the people who are responsible for the maintenance will be able to open that. And once that is done, this cover can be lifted. The maintenance person, whoever is supposed to look after that, will be able to push down himself and come down the steps. Now this area of the manhole is referred to as working space, or referred to as the working chamber. So that is the chamber where you see that now if you look at this figure, you can see this is a figure wherein this is the main sewer that is flowing, and the cross section of the manhole shown to you is at a place where a branch sewer is meeting the main sewer. So the main sewer water, okay, is getting collected or passing through the pipe from here and going out. The branch sewer one comes here, it lets off the water here at this portion. Okay, and this is the cross section shown of the branch sewer, and this branch sewer will be actually very neatly laid down like this. The sewer cannot be left suspended, or the pipe cannot be left suspended. Right? So it will be, this is the way the benching, or what we call by the term bedding, is done. So this is the branch sewer and this is the main sewer. So this cross section A is what is being shown here. The branch sewer comes, and this is where you have the main sewer. So in the case of the manhole, you have a large working area, wherein in this particular cross section they have shown you with respect to where the the branch sewer is coming in meeting. Sometimes it can be for some other purpose also. Okay, just because there is some change in gradient, for that reason also you may have kept a manhole. So for different conditions, a manhole can be provided, and this manhole is provided for where a branch sewer is meeting a main sewer. So the common, what shall we say, components, we can call it as components of the manhole are the access shaft, the working chamber, the bottom portion where you have the invert of the main sewer line, okay, and this portion, this is the invert of the main sewer line. Steps to come down into the chamber, and you have what is called as the manhole cover or top cover. The working chamber is a large chamber, and you will have it of a minimum size 0.9 to 1.2 meters. So that means almost 1 meter height and about 1.2 meter width will be there. And if it is a circular manhole, you can have it in rectangular shape or you can have it in cylindrical shape. It may have about 1.2 meter diameter. The bottom portion, which we are calling as the term benching, or where the invert of the sewer is laid, is kept in cement concrete. And it consists of a semicircular U-shaped channel. So the main sewer, when it comes here, it will be like a U-shaped channel. The pipe will get replaced by a channel there with slopes. Then you have the side walls, which are either of masonry or RCC, and you will have the top cover. So the common question that will be asked to you is, in the case of a manhole, what are its functions? You explain functions and the constructional aspects. So the function of a manhole is basically for inspection, but the location of manhole is decided based on whether the sewer line is straight, whether there is a change in gradient, whether there is a change in direction, etc. And so the manhole will be providing access to enter or for the maintenance personnel to enter, access the working area and check what is the problem that is existing there. So that is the description of the function. Then you need to draw a neat sketch like this, explain what are the components. So you have the top, you have the access shaft, you have the ladders, you have the working area, you have the benching that is provided for the main sewer so that it doesn't move or dislocate. Then you have the bottom concrete bed portion where your walls of the side walls are resting. So this is the cross section of a typical manhole. Now, in this case, this drop is very negligible. I mean, they are meeting relatively at the same level. Okay. In that case, we call those manholes wherein the branch and the main are meeting at relatively the same level. We call such type of manholes as the normal manholes or just simply manholes. But you have another category of manholes called as drop manhole. A drop manhole is a manhole wherein you require a vertical pipe where the branch sewer enters the manhole at a height greater than 0.6 meters. That means the elevation from where your branch pipe is coming and the place where your main sewer is there, the height difference between them is larger. In such case, there is a slight constructional difference in the manhole, and the term they use to define that manhole is also different. So manhole, when we refer, we are saying that the branch and main sewers are meeting relatively at the same level. Whereas a drop manhole is required where the branch sewer meets the main sewer line at a great depth. Sewage is brought in through the pipe which is joining those two is called as a down pipe from the branch sewer to the bottom of the manhole. So just let us take a look at that figure. This will be the figure for your drop manhole. Okay. So structurally it looks similar to the one that we saw earlier, but there's a slight difference. So here again you have the manhole cover, you have the access shaft and the steps, and you have the chamber. This is the main sewer, benching, everything is there. But here you see the branch sewer comes at a little more height from the main sewer. And so this is directly not pumping the sewage here, because imagine if it's coming at such a height and if there is high flow in your, it's going to put a lot of pressure while falling. So what they do, this is the down pipe that we referred to earlier. So it will have a pipe like this, and sewage gets disposed at this portion, which will allow for smoother mixing. Okay, so a drop manhole can be defined as a special type of manhole on a sewer line which is constructed to provide a connection between a high level branch sewer to a low level main, and this depth will be greater than 0.6 meters, so that the sewage does not directly fall into the manhole to avoid. So imagine one person is entering to check something, and if sewage from the main branch sewer is just falling at high force here, all the people who are trying to enter here will get splashed. Okay, so in order to prevent that, but there is a plug. See here, you can see that the branch sewer, when it comes to the main chamber here, it is a seal. So any cleaning or something like that, they have a provision for that already put into place. Okay, but under the normal circumstances, the liquid will flow, go down like this, and get smoothly dispersed at this level. So it will not splash on the people. Okay, so we can have this, which is be called as a drop manhole. The plug is provided where the branch sewer is intersecting with the what to say shaft of the manhole. The that we can call that section of the arm as the inspection arm, because sometimes sewage flow may cause some block here or something like that. By removing the plug and cleaning from here, we will be able to dislocate any solids that are getting stuck there. So that is your second one. So manholes can be shallow, normal depth, or deep depending on their depth below the ground surface. Manholes are basically of two types: the normal manhole, or you will have what is called as a drop manhole. There is one more manhole, but which is not as big as this. So they call it by the term lamp hole. So you know that if sewers are getting blocked, in order to identify, passing light from one end is a very simple process to identify whether there is a block in a sewer line. So a lamp hole is a small such vertical shaft through which you will be able to lower a lamp, viewed from the upstream as well as the downstream, so as to signify if there are, or to indicate if there are any blocks in the pipeline. So it is a simple vertical shaft. So I have the figure here, which allows for the insertion of a lamp through this. It can be made of in pipes, or you can make it as a constructed structure. You just have so much space that a lamp can be dropped, so that a person will observe from here and a person will observe from here, or from manholes which are located there, so that they make sure that the pipe is clear on both sides. So lamp hole is a very simple device which can be called as a special opening, constructed to join a hole in the sewer and the ground for the purpose of lowering a lamp inside the sewer. A lamp hole may be either a vertical concrete or stoneware pipe with a T-junction. Lamp holes may be located where there is a change in direction or gradient of the sewer, or where constructing a manhole is difficult due to some other reason. Okay, so probably when there is a change in direction or change in gradient, chances of materials getting collected are more. Sometimes you are not able to construct a manhole because of some other problem. This requires a very small space. It can be easily constructed. A lamp hole will serve for the purpose of inspection. Okay, an electric lamp can be inserted and the light of the lamp can be observed from either ends. It can help as a flushing. A flushing is somewhere in between, the sewer is blocked. You can pump fresh water from the top. From here you can pump fresh water so that something in this can be cleaned out. It can also provide as a means for ventilation in sewers. So this portion is actually open. There's a gap here. So for lowering the light. So because of that, this also acts like a venting device. So though the structure is very small compared to the manhole, it can serve many purposes and is used basically for inspecting, for venting, and for flushing. These are the main purposes for the lamp hole. Now, similar cleaning device is called as a clean out pipe. Understood? See, you can see a main pipe is there like that. Okay, at about 45-degree angle, they will put a pipe with a plug at the top. These are very simple connections that are done on drain pipes, because in a drain pipe you cannot tell where the materials will get stuck and cause nuisance in the flow. Hence, a clean out is an inclined pipe extending from the ground connected to the underground sewer, which is meant for cleaning purposes. So basically, those pipes are meant for cleaning purposes. Then you have other types of what we can call as appurtenances, which are called as catch basins, or they call it as by the term as inlets, street inlets. Understood? So inlet, I will go to the figure. All these are structures that you commonly see by the side of your road, but because of the pavement, sometimes you will not be able to see this. These are called as inlets. You can have a vertical inlet like this or horizontal inlet like this. Okay, so the purpose of inlet is meant to admit storm water. Suppose there is a rain, the storm water will enter. Okay, through. So this is your road. Okay, and this is your footpath. In between this, sometimes you will see gratings on the road. Sometimes you will see the grating on the curved portion of the road. It can be either ways. The street inlet can be either in the horizontal way or it can be in the vertical way. So inlets are found somewhere in between your footpath and the road pavement, which can either be in this form, horizontal, or it can be in the vertical. So below that, there will be a chamber or a concrete chamber constructed, which is called as the inlet. So this allows the storm water to get conveyed into the stormwater drain or to the sewer if it is a single combined one, and such appurtenances are called as inlets. So if you are defining, an inlet is a device meant to admit the storm water and convey it to a storm sewer or a combined sewer. Inlets are not necessary if you are having separate sewers, but if it is a combined sewer, then definitely, because the storm water is also taken. So if generally storm water is going into the storm water sewer, it's very simple to carry it away, or sometimes it can go in the main drain also. So that is what is meant by a inlet. I have some more figures for you. You would have seen such type of horizontal things on pavements. Okay, these are nothing but inlets. Similar to an inlet, we have something called as a catch basin. Okay, so the inlet is just allowing the storm water to go inside and mix with the combined sewer or go to the storm water drain. But you have sometimes catch basins that are provided. A catch basin, or they call it as a catch pit, is a special type of inlet in which the basin allows the grit, sand, debris, etc. to settle down, and only the storm water is allowed to escape, or only the water portion of it allows to escape into the sewer. I will show you the figure. This is the catch basin. So a slight difference in construction compared to your previous one. So here, the road, the footpath. So in the other case, you had this as concreted and directly the water was going. That was the inlet. This is also an inlet, but a special type of inlet, where the rainwater comes, gets collected, see all the impurities like grit, sand, heavy things that are there in your storm water. It settles down here, and only the clear water goes by. This is called as a hood because it allows for the water to rise and then go, so that none of the impurities which are present in your storm water will enter into the storm water sewer. In a periodic time, these impurities can be dredged out and cleaned from the chain. So a catch basin or a catch pit is a special type of inlet in which you can have the grit, sand, debris, etc. getting collected and settled down. And it also usually traps prevents the escapes of odor from the cylinder and prevents floating matter, etc. to enter into the stormwater drain. That is the purpose for a a catch basin for which is provided for stormwater sewers. We have another 2 or 3 appurtenances remaining, which we will do in the next class.